Hi, welcome to Understanding Complex Exponentials, Lecture 1, Introduction. In this lecture, we'll look at what we mean by complex exponentials. We'll discuss why complex exponentials are useful. We'll list the prerequisites that you need for this course, and we will outline the following lectures. In this course, we're going to cover the relation between complex exponentials and the sine and cosine functions, and give some examples of where complex exponentials are useful for solving problems. So, what are complex exponentials? They are exponentials of the form e to the a, where a is a complex number. A particularly useful expression is obtained for the case where a is purely imaginary, so a equals ix, where x is real. In this case, we have that e to the ix is equal to cosine of x plus I sine of x. Now, exponentials have the convenient feature that e to the a times e to the b equals e to the a plus b for numbers a and b. This can make complex exponentials much easier to work with than sine and cosine functions, and it can simplify a lot of calculations. Because complex exponentials are closely related to the sine and cosine functions, they're useful in geometry and trigonometry. They're also useful in physics applications, such as the harmonic oscillator and waves. And they're also useful in engineering, for example in signal processing. In this course, we'll cover the following topics. We'll derive the relation e to the ix equals cosine x plus I sine x, as well as some similar relations. We'll also look at the graphical interpretation of that relation. We will also demonstrate the utility of complex exponentials in trigonometry by deriving the angle addition formulas, and we'll look at an example from physics, how beats arise in sound waves. Okay, so what knowledge do you need coming into this course? You need to be familiar with the relation I equals the square root of minus 1. If you're familiar with plotting numbers in the complex plane, that's a plus. You need to be comfortable with exponents and the number e. You should be okay with the relation e to the a times e to the b equals e to the a plus b. You also need to be comfortable with angles being measured in radians instead of degrees. However, we will review these concepts very briefly in the following lecture. We should give a note on the ordering of the lectures in this series. So this course does not require the knowledge of calculus. However, in Lecture 3, we start by using infinite series expansions of the sine, cosine, and exponential functions, which can be derived using calculus. We have included derivations of these series expansions in the very last lecture of this course. If you've had calculus and are familiar with Taylor series, it is recommended that you watch that lecture right after Lecture 2, but before moving on to Lecture 3. If not, then we'll ask that you take the series expansions of the sine, cosine, and exponential functions as a given, and we'll suggest that you move straight from Lecture 2 to Lecture 3. Okay, let's give a brief outline of the lectures in this course. After this brief introduction will be Lecture 2, where we review basic concepts like exponentials and plotting points in the complex plane. Lecture 3 will give the relation of complex exponentials to the sine and cosine functions. That lecture will be in 2 parts, Part 1 and Part 2. Lecture 4 will cover the angle addition and subtraction formulas. Lecture 4 will also be in 2 parts, Part 1 and Part 2. In Lecture 5, we'll look at an application, specifically beats in sound waves. In Lecture 6, we'll summarize. And finally, in Lecture 7, we have an appendix, where we give the derivations of the Taylor series for the exponential, sine, and cosine functions.